Hi, Professor. We were all told that a balanced diet is very important for our health. However, it's very expensive to maintain a delicious yet balanced diet. Given a limited budget, how do you know what type of food to get to obtain the maximum nutritional benefits? Well, to answer this question, I did my final project on estimating the minimum price of a balanced diet using Excel solver. So the goal for this project is actually very simple. That is, we are trying to identify a realistic and nutritious diet of the lowest cost for a 24-year-old female to meet her daily nutritional needs. According to Quanometer, a 24-year-old female with weight of 135 pounds and height of 5 feet and 5 inches will need 1,858 calories per day. In addition, she will need a minimum of 46 grams of protein, 130 grams of carbohydrates, and a maximum of 65 grams of fat. In addition, she will need a minimum of 1,000 milligrams of calcium, 18 milligrams of iron, and 310 milligrams of magnesium. Also, she will need 2,334 international units of vitamin A, 75 milligrams of vitamin C, and lastly, 600 international units of vitamin D. All of these will play a role when we set up the constraint for the model. In pursuit for a balanced diet, I chose 3 food items from each of the 5 food categories. For example, I chose apples, bananas, and grapefruits from the fruits category. Also, I chose chicken breast, ground beef cube, and salmon fillet from the protein categories. As a result, there are 15 food items in total. And the row beneath them is the unit cost for each of the food items. For example, we could tell an apple is selling at $2 per pound. And in the table below it is the food quantity associated with each of the food items. These are the variables that we're trying to manipulate to achieve the minimum total daily food cost, which is down here. It is the objective function of this model, and it was set up using the sum product function in Excel. It is the sum of the product between the unit food cost and the quantity associated with each of these food items. Lastly, in this table, we have a summary of the food compositions for each of the food items. For example, from here we can tell a pound of apples will contain 69 grams of carbohydrates, 172 international units of vitamin A, and 285 calories, and etc. Additionally, in the rightmost column is the total for each of the nutrients, and it was set up using the sum product function again. In this case, it is the sum of the products of each the amount of the nutrients and the quantity associated with each of these food items. And all of these here are subject to the constraints that we just mentioned. Now we're ready to run Excel solver. To do it, we will go to the Data tab and hit Solver. For easier demonstrations, before I ran solver, I actually assigned names to the cell range that are needed for solvers. So in our case, we are trying to minimize total food cost by changing the quantities associated with each of the food items. And this model is subject to the following constraints. First of all the quantities need to be positive, and the combination of food will provide the minimum nutritional needs that we just mentioned. For example, it will provide a maximum of 65 grams of fat, a minimum of 18 milligrams of iron, and a minimum of 130 grams of carbohydrates, and etc. And we will solve this problem using the simplex LP method. And if we hit solve, it will return the solutions that you are seeing on my screen. And the combinations of the food items the solver chose is the following. It selected 1.1 pounds of bread, 0.004 pounds of red bell peppers, a quarter pound of salmon fillet, and 0.4 pounds of spinach at the minimum cost of $7.38. Personally, I think 1 pound of bread per day is too much, so I introduced additional constraints on the maximum daily consumption of certain food items. For example, I would like to have less than 0.35 pounds of bread per day, also less than half a pound broccoli, and etc. And the second model returns a more balanced diet, of course at a higher cost. Now you can see more food items are selected. Now bread, broccoli, chicken breast, dry oatmeal, ground beef cube, low-fat milk, low-fat yogurt, salmon fillet, and spinach were selected at a minimum cost of approximately $10. And there you go. This is the minimum price for a balanced diet using Excel solver. I think the most challenging part of this project is to set up the model correctly, especially the constraints. Because if they aren't set up correctly, sometimes solver might not able to achieve a solution. The model may not converge, so you couldn't really find an answer to a question. And the most interesting part of this project is obviously seeing how we could manipulate some of those constraints to obtain a different combination of food at a different amount of food items and also at different cost. Thank you for listening, Professor. I hope you enjoyed this video.